This video covers section 6.4, factoring special products. Objective 2, factor the difference of two squares. When we factor the difference of two squares, we need to recognize the form of the polynomial. And to help us recognize that, we start off with practice problem 3, which says the sum of two terms times the difference of the same two terms. When we multiply the sum of two terms times the difference of two terms, the same terms, we get 4x squared minus 10x plus 10x and minus 25. Because they were the sum and difference of the same two terms, those middle terms are going to cancel out, a positive and a negative. And then because they're different signs, the plus 5 and the minus 5, we'll be left with a minus sign separating the two perfect squares. So the minus sign is described as a difference of two squares. 4x squared minus 25 factors as 2x plus 5 and 2x minus 5. So when we see the sum of two terms times the difference of the same two terms, we can write it as the difference of two squares. If you have 4z plus 7 times 4z minus 7, that's 16z squared minus 49, the difference of the two terms squared. So going the other way, if we see a minus sign and it's a perfect square on both sides, then you take their square roots and recover them and subtract them and add them. When we have a difference of two squares, we take the two pieces and we recover their square roots. P squared is the square of P, and 81, the square root of 81 is 9. So we recover the two pieces, P and 9. We then subtract them, and then we add them. P minus 9 times P plus 9. Example 5, 49x squared. We recover their square roots. 49x squared is the square of 7x. 121y squared is the square of 11y. We've recovered our two pieces, 7x and 11y. So we subtract them and we add them. The difference of two squares factors as the sum and the difference of the same two terms. This leads me to your practice problem. I encourage you to press pause on your video and work this out. And come back and press play when you're ready to see the solution. Now that you've had a chance to work this out, I'll work this out with you. We recognize here that we have a difference of two terms that are perfect squares. 144r squared is the square of 12r. 25 is the square of 5. We've recovered our two pieces, 12r and 5. So we subtract them and we add them, giving us 12r minus 5 times 12r plus 5. Example 6. The first term is 16a to the 10th. In order to write that as a perfect square, 16 is 4 squared, but a to the 10th, if you take 10 and divide by 2, it gives you a 5. So you have to divide those powers on the variables by 2 to figure out the square root. So the first term is 4a to the 5th squared. The second term is 5 squared. We've recovered our two pieces, 4a to the 5th and 5. Once we recover our two pieces, we subtract them and we add them. Four a to the 5th minus 5 times 4a to the 5th plus 5. Example 7, x to the 4th minus 16. X to the 4th, we want to write this as a perfect square. If we take 4 and divide it by 2, that gives us x squared. The first piece is an x squared. The second piece, 16, is the square of 4. Once we recover our two pieces, x squared and 4, we go ahead and subtract them, and we add them. Now we need to be a little careful. We need to check our factors, x squared minus 4 and x squared plus 4. When we check our factors, the first one's an x squared minus 4. That is another difference of squares. We're not done yet with this one. We have to factor this one even further as x minus 2 and x plus 2. So we're going to go ahead and rewrite this one as x minus 2 and x plus 2. The second factor that we propose is x squared plus 4. This one is not a difference of two perfect squares. It's called the sum of squares. This one we don't have a formula for. We have a formula for the difference of squares, but not the sum of squares. So then you ask yourself, how would this thing factor? Or even, does it factor? You would think that you might be able to factor it by using an x and an x, and because it's a 4, you would think you could use a 2 and a 2. But when you check that proposed factorization, you get x squared plus 2x plus another 2x, which is 4x plus 4. The piece didn't cancel out in the middle, so that can't be the factorization of that. There isn't anything else you can try that's going to make x squared plus 4. So we say that the sum of two squares is always prime. So we just leave something that's prime as x squared plus 4. So difference of squares factors and sum of squares is always prime. This leads me to your practice problem. When you look at the two terms, 3n to the 5th, 243n, you don't see a perfect square anywhere. So make sure before you get started on this one, make sure to factor out the GCF, which is 3n. As soon as you factor that out, you will see the difference of two squares. I encourage you to press pause on your video and continue working on this problem, and come back and press play when you want to see the solution worked out. Now that you've had a chance to work this out, I'll work this out with you. We factor out a 3n from both of the terms. Dividing the first one by 3n, we're left with an n to the 4th. Dividing the second one by 3n, we're left with 81. There's our difference of squares. N to the fourth is the square of n squared, and 81 is the square of 9. Our two pieces are n squared and 9. Keeping the 3n in front, our two pieces then are n squared and 9, so we subtract them and we add them. Now we need to check our factors. N squared minus 9 is a difference of squares. That factors as n minus 3 and n plus 3. N squared plus 9 is the sum of squares. Sum of squares is always prime. So we leave n squared plus 9 as is. And so we end up with 3n times n minus 3 times n plus 3 times n squared plus 9. Note, we see that the difference of squares is pretty easy to factor. We also see that the sum of two squares is prime. It seems like when you look at n squared plus 9 that you should be able to factor it. But remember, this n squared plus 9 is like a 0 in front of the n in the middle plus 9. And when we factor trinomials, we say the product of two numbers, that's 9. That adds to then 0. And if your product has to be positive 9, you could use 1 and 9 or 3 and 3. That adds to 10, that adds to 6. You could also use negatives if you want, and that's negative 10, and that's negative 6. You're never going to get 0 if they have the same sign. The only way you can add to 0 is if they have opposite signs, and that's why the difference of squares works. So again, anytime you have the sum of two squares, it's prime. X squared plus 100 is prime. X squared plus 36 is prime. We cannot factor the sum of two squares. And this concludes the video for section 6.4, Objective 2, Factor the difference of two squares.